All right, let's prove this. It says, first of all, the given here. So I've already drawn this in. Mn is equal to ns, and MP is equal to congruent to PS. So there's the given. Now, what I need to prove, that that angle is equal to that angle. So where is that? MQP, this angle right here, MQP is equal to, I'll do it like that, MQP is congruent to SQP, right there. That's what they want me to show. All right, so let's come up with a plan of attack. All right, so what we would like to be able to do is to show that this triangle here, that blue, this green triangle right here, we'd like to show that that's equal to this yellow triangle. If we could do that right away, then we could show that those angles, these two angles here, are equal, because that's what we're trying to get to. But we can't say that yet. We don't have that information. But what we can say, we can use the fact that this is reflexive right here, that line, PN, that line right there is equal to itself by reflexivity, which will give us these bigger triangles equal to each other. This triangle right here is equal to this triangle right here. And that's what we're going to do first, and then we're going to use that fact to establish that certain angles are equal to each other, and then we could use CPCTC. Sorry, using CPCTC, and then we'll go from there to try to prove that those two smaller triangles are congruent to each other. So let me first clean this up. No, that's pretty clean. I like it like that. So let's first start with number 2. Let's say that PN, PN is equal to PN, and that is by the reflexive property.
Yeah, that's right. I'm pretty sure.
And then we can say 3, we can say that triangle MPN is congruent to triangle SPN, and that's by side, side, side.
So the top part of this.
Then we can say.
Okay, so.
Then we can say that angle P. Let me change the color of this so you can see what I'm looking at here. Then we can say that angle right here, SPQ, is congruent to angle MPQ, and that's that CPCTC property. Corresponding parts of congruent triangles are congruent. And now, the fifth thing I'm going to say is that this line right here, PQ, is congruent to PQ. And that reason is, of course, reflexive property again.
Okay, then do it yourself.
And now that I have that, notice that I have a side. I have a side, an angle, and a side. Side, angle, side. And therefore, I can prove that those two triangles, those two smaller triangles, are equal to each other. So we're going to say, number 6, we're going to say that triangle SPQ, that smaller one, is congruent to triangle MPQ. Make sure you're careful with how you label those letters too. And again, that's because of side, angle, side. My first side was the given one right here, MP. That was my first side. My angle was what I just showed right here, and my last side was right here. So that was my side angle side. And now that I have established that those are congruent to each other, I can say my last step, which is that angle MQP is congruent to angle SQP. MQP right here, that angle is congruent to SQP right here, and that's because of CPCTC again. So this is a classic detour proof. In order to prove something, was true, you kind of had to walk your way around it in a different way, kind of look at the bigger picture, and then drill down at the more specific thing, detour proof.